Hi, I'm going to show you a rapid modeling procedure here on a mechanical mount utilizing a lot of the wizards and features inside of Design X that really help us accelerate the reverse engineering process. Right now we're extracting regions, which are geometric groups, similar groups that allow them to be selectable. So planes, cylinders, and so on. Then we're going to use that to apply an alignment. So the origin position at the intersection of the bore with the face. Set our Z normal upward and Y from the front face. Now you can see that we have an alignment completed, which is a required first step. Then we're going to utilize an extrusion wizard. Here we're going to select all the side faces, basically the regions that make up a geometry. For the top, we'll pick one of the main planes. Pick the back, we're going to specify the extrusion direction to be perpendicular to the top plane and also require the sketch to be on that plane. We'll go next. And we can drop our resolution, exclude fillets, and reduce our fitting just so we don't get any small faces and features. We just want the main shape. You can see there, I applied that nicely. I am going to create a vector at the intersection of the two main planes. And I'm going to use that vector along with the Revolve Wizard to revolve cut this bore. I'm going to specify the vector and also the sketch plane and set this to solid cut. Here we'll drop our resolution and our fitting and exclude fillets just so we get the simplified shape. We can add fillets later. So now that's good. I'll hide my vector. So now all I have to do, the mount holes, and we use our mesh sketch feature, a little bit more manual, but still very powerful. Double click on the pink polyline, fits the circles. We'll set this to extrude, and we'll do an extruded cut through all. And then one final circle. Now this I require to be aligned with the origin. So basically on the part midline, and I'll use a constraint line, constrained to vertical for that. So there we go. Now I can use our accuracy analyzer to measure the deviation between the scan and the solid I created. And this is plus minus 4 thou, and so everything is actually quite tight. Now I'm going to do a live transfer, which is a parametric transfer to Solidworks. You can see here that it's recreating our model feature by feature in Solidworks, fully parametric, with sketches. We can edit features, edit the extrusion directions, and continue our design from there. Thanks.